Climate change has been taking a toll on our planet. Rising temperatures, extreme weather, and rising sea levels are all things we will face if we do not stop on our current trend of increasing CO2 output. We are currently trying to resolve problems through green energy and carbon reduction. However, we are still reacting quite slowly, so we might need to take more drastic measures to combat the imminent problem of climate change. Geoengineering is the planned intervention of the Earth's climate. Geoengineering is going to be used to help stop or slow down climate change and our impact on the environment. But how did this all start? How do we know it is us causing the problem? It's 1958, and a scientist by the name of Charles David Keeling moved from his home state of Illinois to Hawaii, where he would establish a base on Mauna Loa for scientific research. He began measuring carbon dioxide, also known as CO2, levels in the atmosphere, and made a shocking discovery. The CO2 levels had been on a steady increase, which is called the Keeling curve. He later connected this rise in CO2 to the rise in the average temperature on Earth. The temperature of Earth had been steadily rising in the past decades, which scientists believe is due to human activities that burn fossil fuels, like coal, oil, and gas. Burning these fossil fuels in our cars, houses, and for electricity releases CO2 into the atmosphere, which interferes with the carbon cycle. The carbon cycle is a natural cycle of carbon throughout the Earth, which keeps CO2s in the atmosphere normal. The carbon cycle works by carbon dioxide being released by volcanoes and respiration from animals and plants, and it is balanced out when forests photosynthesize in the summer and use CO2 to photosynthesize. Then they release oxygen, and that keeps the cycle balanced. Carbon also dissolves in oceans. This cycle has kept the Earth's temperatures and CO2 levels normal. However, the burning of fossil fuels has put more CO2 in the atmosphere than the Earth can take back, which is causing CO2 levels in the atmosphere to rise, and quickly. More CO2 in the atmosphere means the temperatures on Earth will rise. CO2 traps heat by speeding up when infrared light goes to Earth and hits it, which then ricochets back and hits the CO2. When the CO2 is hotter, it moves faster, which in turn causes other molecules to start moving faster, which causes the atmosphere to heat up or trap heat. This causes an increase in temperature or climate change. This increase in CO2 has gone unchecked for decades, and if we do not do something now, we could destroy our only home. Only now are we trying to reverse the damage. We are slowly switching from fossil fuels to renewable sources like wind, solar, and water power. However, we are still converting too slowly, so we need a better and quicker solution to the urgent problem of global warming and climate change. If we do not come up with a solution, and quickly, the consequences could be catastrophic. Sea levels will rise, polar ice will melt, and the weather will become more extreme. For geoengineering, there are 3 approaches that are considered viable, each with pros and cons. The first one is to make the Earth more reflective. This would send some of the sun's light back into space, cooling things down a bit. Also, we could spray sulfuric acid, which would create a haze that would reflect some light. Scientists project we could get temperatures down to normal in 50 years with this method. However, this would cost over $1 billion a year and would rise to $25 billion over time. Another option is called ocean seeding, in which iron would be dumped into the ocean. Iron would serve as a food source for many microscopic organisms called phytoplankton, which pull CO2 from the atmosphere and convert it into oxygen via photosynthesis. However, scientists are concerned that the plankton might not contain all the CO2 absorbed, potentially releasing it back. It could also damage other forms of marine life. The final option is called direct air separation. This involves building air filters that would pull CO2 out from the air, like plants do. It could be through reforestation and crop growth, which could take decades. The natural approach would be too slow to address the urgent problem. Building air filters could do the same thing, except better and faster. We would then have the option to store CO2 or convert it into fuel. This approach is still insanely expensive, and governments are still slow to react to climate change. However, geoengineering could be the only way to meet the standards of the Paris Climate Agreement by 2020.